what is it really like to be a programmer, to be a developer, to learn code, to solve problems with code, to build things with code, those types of things. And I think that what kind of inspired this was, I remember reading like a short Reddit thread about just like what the difference is and what it's like to kind of change mindsets when it comes to like learning how to code and building things. Whenever you talk about actually doing the work of a developer, getting a job and like actually getting in and building things, there's multiple layers to what that involves, obviously. So for instance, with thinking about building products, right? Like there's a certain level in which you have to know, okay, who's my user that's using this product? There's kind of like a way in which you have to enter into your user's shoes, that kind of thing. On another level though, you're gonna be working with data structures, things like that. So it requires that you think how, at the granular level, what this, how to manipulate that data, how to get it to format how you want it to, all those sorts of things. So it requires a little bit of different thinking. And so what I kind of just came up with for me was simply that, like, whenever you think of like what a programmer is, at the very, very end of the day, it's that I'm a really lazy person and I like to build things that do things for me. And programs are just those things. However, the catch there is that computers are really dumb, right? So like you have to tell them explicitly what to do, which is why we kind of have, and there's this kind of term that I like to use with this when it comes to being a programmer. There's this idea of thinking in algorithms or algorithmic thinking. That's literally just like, how do I come up with a repeatable set of instructions for a stupid computer to do? That's all that means. And so for me, like, I don't like any repetitive tasks. I remember I was tasked to make like email signatures for all of our staff once, and I was like, I'm not doing this. So I literally just like wrote a program to like, with an HTML template, took our staff directory and like created all of our email signatures. And it's awesome because if we make a change to it, now I can rerun that program and not have to go through all of our signatures again, you know what I mean, and do that. So again, lazy. The other thing that I want to, especially for people who are new to learning how to code, I think that we're in such an awesome time with this skill that it doesn't require that you have academic level knowledge in order to enter into it, right? So that's the whole reason that we can have a group like this and teach people like, hey, this is something you can do because it's so accessible nowadays. There's so much to work off of. So I always tell people, like, it does not require that you know mathematics, like high level philosophical logic. It doesn't require any of those things. It is something that any of us can do. And that's why I want to encourage anyone that, hey, you can do this. Like, this is super accessible and there's all sorts of resources. That's why all of us, like, I'm self-taught, and I'll know tons of amazing developers in our community who are self-taught also. And I think it's just a testament to, that's why us in this community want to continue to give back and teach other people, because that's super important. Like, we want you guys to have just as many like people to talk to and resources as we did. So at the end of the day, what does all this mean when it comes to like thinking programmatically, thinking, algorithmically or whatever? The very, very first thing to understand with that is, how do I take a problem and break it down into all of its constituent parts, okay? So with this, I'm going to kind of like give some practical advice on how you can continue to build up these skills, as well as like how to think in this way, right? So the first thing that you have to understand is that languages, frameworks, technologies, those things are, when I'm talking specifically on how to think like a programmer, don't matter. You could write it all in pseudocode and pick up the exact skills that you need in order to like make this happen. Obviously, you have to actually implement that with the technology, so that does require language or knowledge of like a language or technology stack or whatever. But this is not like something that you have to know in depth the technology itself before you can start picking up these skills. And a note on that, I would say, so if you're learning how to code, one of the things that I like to encourage is the two major pieces to learning how to be a software developer are what I think are like the skills of learning how to think algorithmically, manipulate data, those types of things, and the technology stack and the implementation side of things, right? So the two ways that you build those at the same time, in my opinion, I'll get to this in a second, is you have to practice both. On one hand, I think you just have to build stuff, right? That's the reason like FreeCodeCamp is so awesome, and FreeCodeCamp's, particularly their Medium blog, is so awesome because there's so many tutorials that you can follow step by step and build something from scratch. They'll just show you how to do it. So building stuff is how you get to build that side of, you know, what it means to be a good programmer. On the other side, though, there are challenges that you reach with respect to how to develop like an algorithm that, like in this case, I used an example last time I gave this talk of like calculating a tip. Like, how do I break down those whenever you are in the nitty gritty of the code itself and you're like, I need to do such and such with this data. How do you break that down into even further steps, right? So encouragement there. When you're building stuff, when you're writing out code, always make sure to like write out the comments, make sure you understand the problem and what you're trying to do before you put code down, and just start thinking of, okay, is this a single unit of work, right? Is this a single unit of a single problem that I can solve? Or ask yourself, could this be broken down into several more simpler problems? I'll skip that for a second. So again, like decomposition, always make sure that you break down everything into your logical parts. If Cal and I were actually just kind of talking about this, like when it comes to like saying like this is my task, this is what I'm gonna do. If it can be broken down any further, then it's not as granular as it needs to be. In my opinion, it always has to be as granular as possible in order to even begin working on it. There are really, really smart developers out there who can kind of like have just kind of all of this in their brain at the same time. For me, going back to what I mentioned in one of the first slides, is like, I don't like keeping a bunch of stuff in my head at the same time. That's why like doing things with programs, doing things with like step-by-step algorithms is so helpful, because you don't have to keep all of that in your brain at the same time. For me, I often will write out whiteboard and just put something on paper that's not code that helps me understand if I understand this problem well enough to even begin writing code for it. So the other thing I wanted to come back to was that when you start thinking about these individual units of work, there are ways in which you can develop this skill of programmatic thinking and algorithmic thinking. My favorite way to do that is whenever I first started learning JavaScript in particular, I started going on to do just practice problems. Practice problems are extremely impractical, so that's the reason I put this here, and I'll post in FreeCodeCamp's Slack with some of my links and resources, but this article right here is essentially defending why he does not encourage people to do what they call code katas, which are like practice problems that are like, you know, reverse this string, or, you know, things that like are really not things that you would do in the real world. There's something to be said about that. I understand this person's perspective, but my response would be that it's okay to say do practice problems and things that are impractical, because that's only helping you develop half of what you really need to do in order to be a software developer in the real world. The other half is a completely different world that code katas aren't even intended to approach. Like practice problems and things like that, they're not intended to approach that. They're just intended to help you understand how to think like a programmer, which is very important in my opinion. So I just wanted to quickly show like what an example of that would be. Okay. So this might be a little hard to see for some of y'all. I don't think I can drag this, but so an example of like a random practice problem. This is one that says implement a function that takes an argument, some sort of what they call an iterable, which is something you can create a loop over, and essentially deduplicate it without changing its order. So you can see here that what they want in this particular one, they have a bunch of repeating characters. Deduplicate each one. So deduplicate all the A's, deduplicate all the B's, C's, and the A's and the B's again, and this should be your your unique array, okay? The same would go for any other, like another string or another array. So now, how much time do I have left, by the way? Or how much do we want to go? Do we want to solve this problem or no? Let's do it. Okay. I think I did it earlier, so it's not that. I can just type it out again. So essentially what I want to do here is the first thing I'm going to need is a loop, right? I need to loop through all of these and say what is in this particular iterable. So I'm going to write that out real quick. My iterable is going to be this, and then I plus plus. This is JavaScript, obviously, so that's how you write a loop in JavaScript. It's almost like they anticipated that. Okay. So essentially what I'm going to do is I'm going to say, I'm going through each one of these steps, right? I'm saying, okay, I'm at the first one, then the second one, then the third one. But what I want to do in order to deduplicate it is say, what was my last value, okay? So the way I'm going to do that is I'm going to declare a variable here like this. I also need to return something, and I don't want to return the thing that came into my function. I want to return something new. So I'm going to create a new array. I'm going to call it, I always call my arrays return array. Okay. I can actually do this, but don't get caught up on that. So what I'm going to do here is I'm going to say if my current value, which in this case is I'm checking what my current value in that array would be, which would be this, is equal to the last one. Actually, what I'm going to say is not equal, because remember I'm deduplicating. So anytime it's a new value, then I want to add it to this array. Right? And if you have any questions about like this code in particular, like just as a matter of like learning more about JavaScript or whatever it is, feel free to ask me afterwards, but I'm just going to blast through this so we can move on. The other thing I'm going to do is I'm going to say I want to keep my current value in order to be the last value in the next round, right? So I would need to compare it. So I'm going to do something like this. I'm now going to assign what the current value is, and the next time we go into the loop, it'll be the last one. So then I'll compare again, and then all I have to do is right? So all this is demonstrating, this practice problem is a completely impractical little thing where maybe actually deduplicating actually might be something that you do in like an actual like product that you're building or a page or an API or something like that. But it's saying, break this into its component steps, and how do I do that? So in my mind, what I just did is I said, I know that I need to return something. I know I need to return an array, and because it told me that I did. I know that I need to compare the last value, and then I know that I need to compare the current value. So I know with my knowledge of JavaScript how to do all those things. I know I can assign it here, and I know that I can get the current value here. And then the rest is kind of just details on how to actually make that happen with JavaScript, right? So my point in really bringing up all that is to say these types of impractical problems are not going to make you a developer, okay? They're just not. They're not intended to either. However, I do think that it's important to know that developers have a certain way of thinking, and these types of problems help you get to there, okay? Let's see if this worked. I might have wrote it wrong. Hey! Okay. All right. Any questions? Cool. Thank y'all.